Hello, Zachariah J here, doing another video for my pre-calc class. This is going to be chapter 3 and 4, test review, part A. I'm going to split this into two parts, so this will be numbers 1 through 18, and then I'll do another video next weekend for the remainder. Um, Please remember, this shouldn't be in lieu of you doing your own homework or practicing. It's just extra little help. I'm by no means an instructor. I'm just taking the class as well. I'm doing this to help out my classmates. So anyway, let's get started. All right, so we got problem number 1 here. A rectangular sign is being designed so that the length of its base in feet is 20 feet less than 4 times the height, h, expressed as an area of the sign in the function of as a function of h. All right, so area of a rectangle was going to be length times the height. Let's do capital L. Yeah. And this here, this side, the base here is really our length, and our height is this over here. We want to express this as a function of h, and they pretty much gave us all the information here that we need, 20 feet less than 4 times the height. So we got 4 times h minus, because the less than 20, minus 20. That's how long our base is, or our length. So we just need to plug that in for L in our area. So we have h times the quantity for h minus 20. And then we can distribute that h out. So we get the area is going to be equal to 4h squared minus 20h. So this one's actually a pretty simple one. It's just kind of plug and play and kind of testing your ability to turn a word problem into a mathematical equation. This one's a little more complicated. A rectangle that is x feet wide is inscribed in a circle of a radius of 13 feet. Express the area of the rectangle as a function of x. All right, so again, we want to know the area of a rectangle, so it's the same formula as before. We have area length times height. And in this case, they gave us a radius of the circle. Here's our length. Oops, wait a minute. Not length and length. This is not a square. It's a rectangle, so we have two different values here. So length and height. And, I mean, we can really mark the bottom as x and this is a y and create a triangle out of this by extending our radius from here to the center, which means this side's 13 over here and this side's 13. So together, these will be 26, right? So our diameter is 26. So we can set this up now as a squared plus b squared equals c squared. Since we already know what c squared is, we'll be able to distribute this into a way that make this a function of x. So we'll substitute x for the a and y for the b and rewrite this as x squared plus y squared is going to equal 26 squared, because we know, oops, 26. So looking at the 13 and wrote 3. All right, so 26 squared, because we know that 13, two sections of that together, added together, is 26. So now we can get this solved down for y, and we will get 26 squared is 676. And we can subtract the x squared from that, moving the x squared onto this side, which is going to leave us y squared on this side. Now we only want one unit of y by itself, so we can just make y equals the square root of 676 minus x squared. Now we'll use that as our y component, and which is really our height. So we can do area is going to be equal to x times the square root of. So area x square root. Yeah, here's the x, and this is what is substituted in for the y. So square root is 676 minus x squared. So there you go. There's number 2. So moving on to number 3. So a wire of length 7 times x is bent into a shape of a square. Express the area A of the square as a function of x. So again, we're looking for the area, but this time it's a square, so all the sides are equal size. And the wire is 7x, so it's 7 times some number. But it's broken up into equal parts, 4 equal parts. So we can just put 7x here, and since we have 4 sides, we know that they're equal. So we just put 4 under here. So 7x over 4 is how long each side is going to be. Now, darn it. We'll plug in the 7x over 4 into our equation. And we can actually distribute this out. So we'll just do a is equal to 49 over 16x squared. And there is our fully expressed equation for number 3. Number 4, a box with an open top is to be constructed from a rectangular piece of cardboard with dimensions 13 inches by 20 inches by cutting out equal squares of sides x at each corner and then folding up the sides as in the figure expressed in volume. Express the volume V of the box as a function of x. So we got 20 is this length and 13 is this height. And we have all these little X's all over the place in here. Our volume is length times width times height, or any combination of that. So I'll just mark my length here. This is going to be my width here. And this is going to be, X is going to be my height. So just know that this is actually the height in the 3D dimension box. If I can get my pen to work right. Still doesn't look the best, but I made it a little too small. Anyway, well, we just need to find length and our width and our height. So our length is 20 minus 2x, because we're cutting out 2 lengths of x from the corners there. This x and this x. So we're subtracting those 2. And our height is exactly the same situation, except it's 13, but 13 minus 2x again, because we were told that these are squares we were cutting out of the corners, which would make sense. So that's our width. And our height is only 1 unit of x, because these corners are getting folded up. That's kind of why we have that second picture, to kind of show you that. So basically, we're just going to sub in all of these for our equation. So we got the quantity 20 minus 2x for our length. And then we've got times the quantity. What am I doing here? Okay, times the quantity 13 minus 2x. And then that, of course, is going to be times x, which is our height. And that's our volume. I don't really like having the x trailing there, so I'll just move the x to the front. 20 minus 2x times the quantity 13 minus 2x. And those can all be in whatever order you want, but there you go. there's that one. Also pretty simple. This next one's a little more complicated. I had to kind of really think about this one for a little while. The price P and X, the quantity of a certain product sold, obey the demand equation. And the equation they gave us is P equals negative 1/10 X plus 100. So the first question is express the revenue R as a function of X. And this is what kind of confused me for a bit, but the revenue is the number of items sold times the price. So it doesn't really expressly say that in the directions, so it's kind of hard to tell. So really, we take x. X is equal to the number of items, right? Even in the original equation, it's the quantity of a certain product sold. So x is the number of items sold, or number of items, times the price, which is P is the price. So really all we need to do is say that x times P, and that's what R is equal to. I'm not explaining this the best way possible, probably. It's very confusing, but the function R of x is equal to x times the original equation they gave us, which is negative 1/10 x plus 100. And then, of course, we can distribute that out to be negative 1/10 x squared plus 100x. So negative 1/10 x squared plus 100x. So that's our answer for A. Then we look into B. What is the revenue if 450 units are sold? Well, we're just going to take 450 and we're going to plug it into our equation. So we're going to plug it into that equation that we just created, not the original equation, because we want the revenue. So we have negative 1/10 times 450 squared plus 100 times 450. And because we end up with, let's do 450 times 450. I'll just do that long multiplication really quick here. Just bring down to 0. 5 times 0 is 0. 5 times 20, nope, 25, not, there we go, 25. And that's 22. And then put down our next 0. 4 times 0 is 0. 4 times 5 is 20. 4 times 4 is 16. Plus 2 is 18. Add that all up. And we're going to get 202,500. But then we're going to multiply it by a negative 1/10. So 1/10 of this basically is going to kill one of these zeros. So we get negative 20,250. All right. And that's going to be plus, and that's going to be 45,000. Yeah, 45,000. Just add the two zeros because we're multiplying by 100. That makes it a little easier. So this is really kind of a subtraction problem. 45,000 minus 20,750 and 24,750. Yep. So this equals 24,750. That's our letter B. Now, letter C up here, graph the revenue function using a graphing utility. We're not going to be able to do that in our class. We aren't allowed to use graphing calculators for our tests, so this will not be on the test. So we'll move on to D. What is the quantity X maximizes revenue, and what is the maximum revenue? So this problem, I'm just going to use the negative b over 2a to pull out what the x should be. And then we'll plug that number back in and to the original equation, we'll find out what our max revenue is. So we got negative 100 over 2 times negative 1/10. This is just going to be a bunch of ugliness. Negative 100 over negative 2 over 10. And that turns into a reciprocal multiplication problem. So negative 100 over 1 times 10 over negative 2. So that gives me 1,000 over 2. Both of those are negative. But a negative divided by a negative turns into a positive. So this is going to be positive 500. All right, so that's the quantity that maximizes our revenue. Now we're just going to take that quantity and plug it back into our original equation. So we have negative 1/10 times 500 squared plus 100 times 500. And 500 times 500 should be 25,000. Let's do it real quick. Drop down 2 zeros and then another 2 zeros, 5 times 5. Yep. And then multiply that times negative 1/10, and that gets rid of the zero. So we get 25,000. Negative 25,000, because it was times a negative 1/10, plus 500, or 50,000, sorry, which means that this is going to equate to max revenue of $25,000. So our max units is 500, and our max of R is going to be $25,000. So that's number 5. That one threw me for a loop for a little while. So, all right. So let's move on to E. And what is this price if we maximize its revenue? Well, it's 500, except for we need to put that back into our original equation. So we got negative 1/10 times 500 plus 100. And it's pretty easy to see we're going to get negative 50 here. Negative 1/10 times 500 is basically eliminating a zero and putting the negative sign there, plus 100, which is going to be 50. So 50 bucks. That is what we should do. This is actually an E, not a C, I know, but yeah. $50 is the price that we should charge to reach that maximum. All right, number 6. Find the vertex and the axis of symmetry of the graph of the functions below. All right, so we've got negative 2x squared minus 20x, and that's all equal to 0. Well, I'm going to show you 2 different ways. I'm going to do the long way first, so version 1 or method 1. So factoring out a 2 here, and then we're going to complete this square. So to complete the square, we would need 25 here. 25 times negative 2 is negative 50. So we have to add the negative 50 to the other side of the equation to balance this all out. Now, of course, this is going to be, whoops, wait a second, negative 2, and this factored down would have been x plus 5 squared. And then moving that negative 50 over is plus 50. And so this is our function of x. And so our vertex is the opposite of what's inside the quantity there. So it's negative 5 and plus 50. So that is our vertex. And our axis of symmetry is x equals negative 5. Guess I don't really need to bracket there, but square that off. The x plus 5 is supposed to be, that quantity is supposed to be squared. But anyway, this is version 1 or method 1 to get you the answer for this question, method 1. On these next ones, I'll do method 2. This way should be a little bit quicker and easier, but I won't make that squared mistake this time, hopefully. So we have x is going to be equal to negative b over 2a. So if we look at our b in here, it's plus 6. So we'll just make that a negative 6 because it's supposed to be negative b over 2 times, and our a is 1 because there's nothing out in front there, so it's 2 times 1. So we get negative 6 over 2, which is negative 3. That is the x portion of the ordered pair for our vertex. Now to find out what the y is, we just plug that into our original equation. So it's negative 3 squared plus 6 times negative 3 plus 8. So negative 3 squared is 9 plus 6 times negative 3, that's going to be negative 18, and plus 8. So 9 plus a negative 18 is negative 9 plus 8 is negative 1. So our ordered pair is, for our vertex, is going to be negative 3, negative 1. Vertex, negative 3, and negative 1. And our axis of symmetry is just the x portion of that ordered pair, so it's x equals negative 3. That would be the vertical line that this parabola would be reflected across. Okay, so number 8, I'll use the same method here. X equals negative 13 over 2, sorry. And that can't be factored down any or reduced, so this is going to suck. So we'll just plug negative 13 over 2 into our original formula. So negative 13 over 2 squared plus 13 times negative 13 over 2 and minus 6. All right, negative 13 times negative 13, it's 169 over 4, because 2 times 2 is 4, minus, because negative 13, or 13 times the negative 13 was going to give us 169 again, but over 2, and minus 6. Now we have to get common denominators here, so this is going to be really minus 338, I think. Multiply that by 2. 18, yeah, 338 over 4. And then minus 24 over 4. Now we have all of our common denominators. So 169 minus 338, kind of, let's reverse those in my, I can't do this in my head. 338. Go the long subtraction method here. I'm brain locked. 9 from 18 is 9. 6 from 12 is 6. And 1 from 2 is 1. 169. Oh, man. I should have totally been able to see this. I just did this in my head the other direction. Anyway, I'm going to add 24 to this. I'm subtracting. Why am I subtracting? I need to add 24 to this because I'm already negative. So get the eraser out here. Just couldn't stop myself. Okay, so I'm at negative 169, and I am subtracting another 24, so really I'm adding to this number, so it should be 39,193. So my answer here is negative 193 over 4. Oh my gosh, so much yuckiness here. So my vertex is going to be negative 13 over 2. And the y component is the negative 193 over 4, because that doesn't look like it can be reduced any further. So our axis of symmetry is, again, just the x-coordinate of this ordered pair, which is negative 13 over 2. All right, there's our answer to that one. Oh my gosh, so much yuck. Yuck. All right, number 9. Again, we're going to do our negative b, but since we have negative 2, it turns out to be just a positive 2 times 2 times negative 4, which is going to give us 2 over negative 8, which is going to give us a negative 1/4. So x is equal to negative 1/4. So plug that into our original equation. Squared minus 2 times negative 1/4, and then minus 9. So much yuckiness here. Okay, so let's take care of this part first. It's going to be negative 4 over 16, because 4 times 4 is 16, but that can be reduced back down to negative 1/4. Right back where we started. So make sure in my head that that is correct. Let's see, 4 times 4 is 16, so 1/16 positive and negative 4. Yep, that's going to be negative 4/16. So it is equal to negative 1/4. It worked out so nicely, I had to second guess it. This next part is negative 2 times negative 1/4, so that's going to be positive 2 over 4. We'll leave that. We won't reduce that one because we're going to have to get common denominators anyway. Minus 9, which is 36 over 4. Yeah. There we go. So negative 1 plus 2 gets us to 1, minus 36 gets us back down to negative 35. So 35 over 4, and that's negative. So our vertex is negative 1/4. Our second ordered pair is negative 35 over 4, which can't be reduced any further, so just leave it this way. And our axis of symmetry is just the same as all the rest. It's the x portion of this ordered pair, which is x equals negative 1/4. And that is the answer for number 9. More yuck. These fractions are ugly. But anyway, moving on, number 10. Determine, without graphing, whether the given quadratic function has a maximum value or a minimum value, and then find that value. Now, since there's no negative out front, that means we have a parabola like this, pointing up. So we are going to have a minimum value. I mean, that's what's going to tell you right off the bat if you have a minimum or maximum, if there's a plus or a negative out in front here. So we have a minimum value. We just need to find out what it is. So our negative b over 2a is going to help us again. So just write that equation here, help us out. So we have negative 2, which is 2, over 2 times 1, which is, again, 2. So it's 1. Plug 1 into our original our equation. 1 squared minus 2 times 1 plus 1. That's going to be 1 minus 2 plus 1. And that's going to equal 0. So our minimum value is 0. Remember, when the equation is asking for the value, it is asking for what is going to be the output of this function putting in the x. So we have minimum value of 0 here. So remember, this part of the word problem is the important part here, value. All right, move on to number 11. So this is positive again. So we are going to have a min value. Get rid of this circle real quick so you can see the original equation. Oops, not the rest of the 4. All right, so it's a positive 4, so we're going to get a min value. So negative 2 over 2 times 4, it's going to give us 8. So we're going to have negative 1/4. So plug in negative 1/4 to our original equation to find out what our output's going to be. And our output, let's see, we're going to have 4 times negative 1/4 squared plus 2 times negative 1/4 again minus uno, or 1. All right, negative 1/4 times itself, that's going to give me 4 over 16 times the 4, which is, again, comes out nice and easy, just like the last problem. Turns out to be 1/4, just no negative this time. Plus negative 2 over 4, so it'll be minus 2 over 4. That positive 2 times a negative 1/4, change it to a negative. Minus 4 over 4. 1 turns into a 4 over 4. So we have 1 minus 2, that's negative 1, minus 4 more, it's negative 5. So we have negative 5/4. So our min value for number 11 is going to be negative 5/4. Not too bad. Number 12, just another one of the same process. Again, it's positive, so we're going to get a min value. We have negative 3 over 6, which equals negative 1/2. That's what our x value is, so plug that into our equation. 3 times negative 1/2 squared plus 3 times negative 1/2. And let's see, that's going to give us 3 over 4. So 3/4. The negative's gone. Minus, because the plus times the negative gives us the negative, 6 over 4. That would be 3 over 2, but we have to get like denominators. And so we are going to have negative 3 over 4, which can be reduced. So our minimum for this guy is negative 3/4. Little Super Mario Brothers in there. All right, number 13. This time we have a negative out front, so that means we are going to have a parabola that opens down. So we're going to have a max value for this. So here would be our parabola, something like that. I mean, it might not be above the x-axis like that, but you get my point. It's a U pointing down, so we have a max value this time. Same process as all before. X equals negative b over 2a, so x is equal to 10 in this case because it's negative 10, negative, negative, it's positive. And we have negative 5 times 2, which is negative 10, so it's going to be negative 1. Plug that into our original equation. We have negative 5 times negative 1 squared minus 10 times negative 1. So negative 5 times negative 1, or actually it's going to be times positive 1, negative 5 plus 10 is going to be equal to 5. So our max value is going to be 5. Kind of actually close to what I sketched there, as a just throwing it out there. Anyway, number 14. All right, well, again, we have this negative out front, so we know it's going to be pointing down, so we're going to have a max value, so I might as well just write that over here, max. That's what we're looking for, is a max. Super max. So we have 2 over negative 10, so 2 times negative 5 is negative 10, so we have 1 over negative 5, so it's negative 1/5. Plug that back into our original equation. Minus 2 times negative 1/5. Negative there, minus 4. All right, so it's going to be 1/25th. And then, right. I'm trying to go faster and it's making me go slower. Yes, yes, this is 1/5 squared is 1/25th times 5. That's 5 over 25. It's going to get us back to 1/5. Ah, but it's going to be negative. All right. Minus, actually it's going to be plus, because negative 2 times negative 1/5 is going to give us 2/5, positive 2/5, minus 20 over 5. So we're going to have negative 1 plus 2, so that's 1, minus 20, negative 19. So here we're going to have negative 19 over 5. Here I'm trying to go faster to make the video shorter, and I think it's making me brain lock a little bit here. So negative 19/5. That's the answer for number 14. All right, so now I'm going to move on to number 15. Solve the inequalities. All right, so x squared minus 2x minus 15. We're going to have to use our quadratic equation here. Negative b plus or minus the square root of b squared minus 4 times a times c, and that, of course, all over 2a. This is our quadratic equation formula. Right, so I just need to figure out what a, b, and c are. Our a is 1. The coefficient of our b is negative 2. And the c is negative 15. So I'm just going to take all these numbers and plug them into that quadratic equation. So we have negative 2 in for negative b. Negative and negative makes it positive, so it's 2 plus or minus the square root of negative 2 squared plus 4. I'm sorry, minus 4. Wow, what am I thinking? Times 1 times negative 15. I'm getting ahead of myself because I know that's going to turn into a positive. 2 times 1, so let's just leave 2. I mean, technically this is 2 times 1 because that's a, but 2 times 1 is 1, or 2 times 1 is 2. So the 1's gone. All right, so let's look at just this part of it and try and reduce this part down. And 2 times 2 is 4. Negative 2 times negative 2 is 4. Minus 4 times 1 is 4. And then 4 times 15 is 60, right? Do it the long way here. And 0, 4, 5, 6. Yep, 60. And since they were both negative 4 and negative 15, so it's going to be a positive. So we're going to add 60. So that turns into 64. And of course, that is under the radical. So it's a square root of 64. So we have 2 plus or minus square root of 64, but that's 8 Um, and that's all over 2. Then we can reduce this all down, so we can get rid of this 2. That 2 turns into a 1, this 2 or 8 turns into a 4. So I have 1 plus or minus 4. So that means this can either be 5 or it can be negative 3. But remember, our original inequality said it can be less than or equal to. So when we write these two coordinates, or these two values, we need to open bracket for negative 3 because it includes negative 3. And it also includes 5. So make sure we have the open brackets, not parentheses. So that's number 15. Now number 16. All right, so we got to distribute that to negative 15 over to this side. So we have 4x squared plus 15x minus 25 is less than 0 because there's nothing left over there. We took this, we moved it over here, and we changed it to a plus. So that's where our 15x, or plus 15x came from in the middle here. All right, so we have our quadratic formula, minus b plus or minus the square root of b squared, minus 4 times quantity a times c, all over to a. And the reason I moved all this stuff around again was to make it easier to see what my a, b, and c are. My a in this case is 4, my b is 15, and my c is negative 25. I'm just going to take all those values and I'm going to enter those into my equation. So minus b is minus 15, plus or minus square root of b, which was 15 squared, minus 4, times our a, which is 4, times c, which is negative 25, and that all over 2a, which is 2 times 4. All right. So let's just look at the part that's inside the radical here and try and get that into a nice, neat package. So 15 squared is going to be 15 times 15, which is 5 times 25, and it's 5, 7, so it's 75, so 15, of course, so 5, 7, let's see, 12, yeah, so 225. So 15 squared is 225, and then let's look at the let's look at the negative 4 times 4 times negative 25. So negative 4 times 4 is going to be negative 16. And then multiply that times negative 25. And that's going to be 30. So that's 8. And then 16 times 2 is 32. So I'll just write that down. Got 0, 10, 4. And since these were two negatives, it's going to be a positive, so plus 400. So plus 400. That's, of course, under the square root. Add those together, we get 625 under the square root. And 625, I believe, is 25 times 25. I think this works out nicely, so let's just check. 25 times 25. 5 times 5 is 25. That's 7, 10, 12. And then that's 50. Add these together. Yep, sure enough, 625. So 25 is our answer here. So that means we have negative 15 plus or minus 25 over 8, which, yeah, that's 2 times 4. That's where we get the 8 from. So really what we end up getting here is negative 15 plus 25 gives us 10 over 8, right? 10 over 8, which equals 5/4, because that can be reduced. Or we can go the other way, negative 15 minus 25, which is going to be, what is that, negative 40 over 8? Yeah, 25 plus 5, yeah, negative 40. Yep, over 8, which works out nicely to 8 goes into 45 times, so we get negative 5. Now, remember, this is a less than. There's no equal than included here, so it's just less than. So we don't make the bracket. We do an open parenthesis, so it's negative 5 to 5/4. And that's the answer for number 16. All right, number 17 here. Again, just like last problem, we are going to have to move that 90x over. So we have 25x squared minus 90x here in the middle. Just distributing that across, plus 81. And that, of course, is going to be less than 0 now that we've left nothing else left on this side, so it's 0. So this makes it easy for us to see our ABC. So our A is 25, our B is negative 90, and our C is 81. Now we're just going to plug that all into our quadratic formula. So it's 90 plus or minus, and then that's going to be negative 90 squared minus 4 times 25, and that times 81, and then 2 times 25 is going to be 50, so this is all going to be over 50. All right. So I've got everything kind of as best I can except for what's under the radical here, so let's just focus on just that part of it. Negative 90 times negative 90 is going to be 8100. Let's just do the long multiplication because I don't trust myself today. 0, 0, and 18. And then the other side is 100 times 81, and that is going to be 8100 as well. See, this is why I don't trust myself. I wrote that 18. I added 8100 on this side, and this side is going to be negative 8100. And so what we end up under the radical is 8100 minus 8100, which comes out to be the square root of 0. And that means there's only one solution here. And for this parabola to work, it has to kind of have 2 points. It means it's really not touching the x-axis here, so there's no real solution here. You can't have a plus or minus 0, so no real solution. So there you go. Now we'll move on to number 18, our last problem for today. Number 18 says, if a rocket is propelled upwards from ground level, its height in meters after t seconds is given by h equals negative 9.8 t, this should be t squared, plus 98t. During what interval of time will the rocket be higher than 235.2 meters? Okay, well, we want to know, better hurry, running out of battery here. So we want to know when the rocket is above this altitude. So that means we have the negative 9.8 t squared plus 98t. We want to know when it's greater than the 235.2. So let's distribute this over t squared plus 98t and minus 235.2. All right, so this is our equation. We're going to enter in our quadratic formula. So we have 9.8 turns into 98 over 10, which we can get down to 49 over 5. Here we go. And then these are supposed to be negatives. That's my fault. All right, so that means we have negative 49 over 5 times t squared just trying to get rid of all of these decimal places. So this would be plus 98t, of course. No decimal place in that one. And then this 235.2, we got to get rid of that decimal. So it's 2,352 over 10. And to get that into like terms with the over 5, I mean, this cut in half. So this will be 1176 over 5. So it's minus 1176 over 5. So now I can, let's see if 49 fifths factors out of this nicely. Here's hoping. So t squared plus, actually it's going to end up being a minus. So let's see, 98 divided by 49 fifths, negative 49 fifths. Can't do that one in my head, so we'll do 98 over the negative 49 fifths, which turns into 98 over 1 times 5 over negative 49. So 5 times 98 is, can't do it in my head. Gotta use this. That's 40, 45 plus 4, 49. Ooh, look at that. 490. This is looking good, fellas. 490 over negative 49. That's a negative 10. Nice. All right. Negative 10. Yep, for sure. Okay, so we'll stick that over here. And that's going to be 10t. Of course, minus 10t. Let's see if our luck continues. And 1176 over 5 divides evenly by negative 49 fifths. And this is going to end up being a positive because it's negative divided by a negative. So we have negative 1176 over 5 times 5 over negative 49. So, yeah. All right. What do we get here? 1176 times 5 is 0. 35, 38. That's going to be 8. And that's going to be 5. So 5880. And then we're going to have 49 times 5. That is 45, 24, 20, 45. All right, so we have 5880 over 245. I'm going to spare myself the long division here and actually use a calculator real quick. Just hang on one second. And this works out evenly as well. So it's 24. So very nice. So we got 24 here. Now we can factor what's inside the parentheses here. So we can find out our two values we're looking for. So factoring t squared minus 10t plus 24. I think negative 6 and negative 4 will give us 24, and added together would give us negative 10. So yeah, 6 and 4 will work. So we have t squared minus, which way should we do it? Let's do the 4. T minus 6t plus 24. There we go. Now we can factor out a t from this side. So we get t times the quantity t minus 4 minus 6 times the quantity t minus 4. Excuse me. excuse me. So we get t minus 6 times t minus 4. And of course, the negative 49 over 5 is still out in front of all of this junk. So really, we can get 6 or 4. Either one of those numbers in there would make this all 0. So remember, it's less than 0, though. So we're going to put 4 is less than t, and t is less than 6. It doesn't include 6 because we don't have a less than or equal sign. So really, here's our answer. But why? Why would this be our answer? So here's my theory behind this. We're going to have ourselves a little grid here of time over, and this side is going to be our height in meters, of course. And it told us we had this little rocket, right? This rocket shooting up. Draw a little rocket here. Rocket man. Rocket needs to have some flames, so let's put some flames behind the rocket here. And our rocket is going to be on this trajectory of up, but at some point it will, oh crap, better do this quick, run out of battery. So we'll eventually be coming back down, and we're only interested in stuff that's over 235.2 meters. When it comes down over here, it's going to crash and make a bunch of flames. So 235.2 meters. And 5.2. And that is going to be basically this line across here. But the question asked us, when is it going to be above? On what interval? Well, since it goes up, it must come down, right? So it'll be above at this 2 points that we found, 4 seconds and 6 seconds. Of course, I guess we don't really know if they're seconds or minutes, but if it took it 4 minutes to get to 235.2 meters, it'd be a really slow rocket. But anyway, this is why I'm theorizing why you would have a time interval like this. So anyway, that's the answer for number 18. You don't need the graph part of it. I just did that for fun. But this is the first half of our review. Again, remember, I'm not a teacher. I make mistakes as well. You know, teachers, I guess, they make mistakes too. But I'm just a student. So if you're one of those people that's like not going to study or not going to practice on their own, I strongly discourage you from doing that. You really need to do practice through all of these problems on your own. If you get stuck, that's where this video might be helpful. But even if you watch the video and go, okay, now I'm going to go try them on my own, that's fine. Just wait a little while and then see if you can go through it. Certainly don't rely on me as getting the perfect answer or the right way to do it. Make sure you know how to do it yourself. I'm not going to be there to help you with the test anyway. You're going to have to do that on your own. So anyway, good luck on the test, and I'll do the other half. Let's see, what is it? We did through 18 today. So we'll do 19 through 36 for the next half of this video, and I'll try and post that up next weekend. So, or this coming weekend, actually. So anyway, have a good night, rest of your week. Talk to you later. Bye.